Hi and welcome to Maths class. Today we're going to start looking at antidifferentiation. We're specifically going to look at indefinite integrals. We looked briefly at definite integrals, although we haven't really learned how to do them yet. We've learned about the theory. So today what we're going to learn is how to do antidifferentiation, and it's pretty straightforward because we already know how to differentiate, and antidifferentiation is exactly the opposite of differentiating. So if you have a look at the graphs I've got there, they're a little small, I'm sorry. But what I've basically sketched for you there is the graph of y equals x squared plus 2 and y equals x squared minus 5. Now, what I'm going to add to this now is a graph that's the straight line y equals 2x. Now, you know that y equals 2x is the derivative of y equals x squared plus 2. But it's also the derivative of y equals x squared minus 5. So what's going to happen when I want to anti-differentiate y equals 2x? How do I know which of those two graphs is the correct antiderivative? And the answer to that is we don't know. Okay, in fact, every graph when I anti-differentiate is going to have, every function that I anti-differentiate is going to have more than one solution to that. So let's have a look at how that looks when I actually do it. So what you see there, so here is the indefinite integral of 2x. So because when I differentiate x squared, I get 2x, that means when I anti-differentiate 2x, I get x squared. Now my notation is this sort of long stretched out S shape, which just means the general antiderivative or the indefinite integral. Now that becomes a definite integral if I have terminals on the end here and I'm looking at an interval from one x value to another x value, which is what we saw in our last lesson. But we don't have that here, so that means we're looking for a general antiderivative of 2x with respect to x. So that's dx. We always put our dx's on the end. If you forget your dx, you're going to lose marks, so please remember them. So that means the general antiderivative of 2x is x squared plus c, because I know that if I differentiate this, there could be something added, which when I differentiate it gives me a value of 0, and I don't know what the something is. So we always write our plus c's. And again, don't forget your plus c's. All right, so what that gives us in general is that if I have some function capital F of x, and I differentiate it to get capital F dash of x to get small f of x, right? So if f of x, small f of x, is equal to the derivative of capital F, then that means the antiderivative of small f is capital F of x plus c, where c is an arbitrary real number. All right, so that's notation, but how do we actually do it? So what we're going to do now is we're going to explore what we know about derivatives in order to find out how we can find antiderivatives. So we're looking today at the antiderivative of x to the power of r, and I'll talk in a minute about why r cannot be -1. So these are some functions that we know, and we know how to find the derivative of all of these. What we do is we look at the power, we subtract 1, and we multiply out the front by the power. So x squared, I take that power out the front to be a 2, and then I subtract 1 from the power, which gives me x to the power of 1. The derivative of x to the power of 7, I put my 7 out the front, and I subtract 1 from the power. X to the power of -3 out the front, and then x to the power of, remember when I subtract 1 from -3, I get -4. When my power is a fraction, it works in exactly the same way. I take my fraction out the front, x to the power of, now it's going to be a half, minus 1, which gives me -1/2. So that's how we find the derivative. So what that means in all of these cases is the antiderivative of 2x, for example, dx, is x squared plus c. The antiderivative of 7x to the power of 6 dx is x to the power of 7 plus c, and so on. The antiderivative of negative 3x to the power of negative 4 dx is x to the power of negative 3 plus c. And the last one, the antiderivative of 1/2 x to the power of negative 1/2 is going to be x to the power of 1/2 plus c. So I know how to get from here to here. How did I get from here to here? Well, I multiplied by 2 and I subtracted 1 from the 2. So to get from here to here, I divide by this 2, but I don't have a 2 yet. So what I want to think about first is adding 1 to the power to reverse that process, and that's going to give me 2, and then I will divide by 2 and that will get me here. Let's test it out on the next one. X to the power of 6, we add 1 to the power, which will give me a power of 7, and then I divide by that new power of 7, so I'll get 7x to the power of 6, to the power of 7 over 7, and those 7s will cancel and disappear. So let's look at a couple of examples going that way. Here's my function. Here's the derivative. So if I didn't know the original function and I had the derivative, if I had a derivative of x cubed, to find the original function, I need to add 1 to this power, which is going to give me x to the power of 4, and then I divide by the new power. Now let's just double check this. If I were looking for the derivative of this function, I would take that 4, I would multiply it out the front, and those 4s would cancel, and then I would subtract 1 from the power, which would give me x cubed. Let's do another one. If I have x to the power of negative 2, let's first add 1 to the power. So remember, we're adding 1 to the power, not subtracting. So x to the power of negative 2 is going to become x to the power of negative 1. And then I divide by the new power. So I divide by negative 1, and I won't leave it like that. I'll write it as negative x to the power of negative 1. So that's basically how we find the antiderivative. So that brings us to our general rule. The antiderivative of x to the power of r with respect to x is x to the power of r plus 1. I've added 1 to my power, divided by r plus 1, which is the new power, and I always add my plus c. Now, I said before that I would talk to you about why r could not be negative 1. So I've got here that r is an element of the rational numbers excluding negative 1. We will only deal with rational numbers, okay? But it can't be negative 1, because if I take r as negative 1 and then I add 1, I'm going to get 0. Now, x to the power of 0, that's not a problem. That's just 1. But then I need to divide by that new power, by 0. That I can't do. Now, that doesn't mean that I can't find an antiderivative when r is negative 1. I can, and we'll see how to do that in the next section, but I have a different technique to do that. So let's look at some examples. So here's my first worked example. I need to find the antiderivative of 5x to the power of 4 minus 2x to the power of negative 3 plus 2 with respect to x. So all I'm going to do is, for each of these, I'm going to find the antiderivative by adding 1 to the power and then dividing by that new power. So I'm going to get x to the power of 5 divided by 5, but I'm already multiplying by 5 there, so it's just going to be x to the power of 5. Now here I've got negative 2x to the power of negative 3. So if I add 1 to the power there, I'm going to get x to the power of negative 2. And if I now divide by negative 2, then that's going to be negative 2 over negative 2. So it's simply an addition here. X to the power of 5 plus x to the power of negative 2. Now, just remember that 2 is the same as 2 times x to the power of 0. So if I've got x to the power of 0 and I add 1 to the power, that's going to give me just x. And I still need to keep my 2, and it's added. I'm dividing by 1 in this case. And finally, I need to add my plus c. Now, I want to check this just quickly using the knowledge that I have of differentiation. If I differentiated this equation, I would get 5 times x to the power of, subtract 1 from the power, that's 4. Then negative 2 times x to the power of, subtract 1 to the power, that's negative 3. Plus 2 times, well, x, subtract 1 from the power gives me 0, so that's just plus 2. And then the plus c becomes nothing. So I've done a quick check that yes, this matches what I started with. When you're just learning to anti-differentiate, it's a nice idea to check your answers by differentiating. Not just because it'll help you find mistakes, but it will help you reinforce the process that what we're doing is undoing what we do when we differentiate. So here's another example. Find y in terms of x if dy dx equals 5 root x. This is exactly the same question, okay? All I need to do here, I've got the derivative of some function, y equals something. I need to know what that function is. I only know the derivative, so I need to anti-differentiate. So y equals, it's going to equal the antiderivative of 5 root x. But before I can do this, I'm going to just start by rewriting 5 root x as 5 times x to the power of a half, because that will help me when I'm adding and subtracting my powers. So I need to add 1 to this power. So I'm going to have x to the power of 3 over 2, because that's a half plus 1. Keep my 5, but I need to divide by 3 over 2, the new power. Well, dividing by 3 over 2 is the same as multiplying by 2 over 3. So that's going to give me 10 x to the power of 3 over 2 over 3. And don't forget, I need my plus c. All right, I have one more example. Oops, that's not it. Here it is. A curve has a gradient of 3x squared at a point xy and passes through the point 1, 3. Find the equation of the curve. So what we're really told here, we've got to interpret this question, is we're told the gradient is 3x squared. In other words, that's the derivative. And I'm also told that the original curve passes through the point 1, 3. So I've got more information in this question than I usually have. So what I'm looking for is the antiderivative of 3x squared with respect to x. Well, that part's easy. I add 1 to my power, it's going to give me x cubed, and I divide by 3, but I've got a factor of 3 here, so it's just going to be x cubed plus c. So far I know that my equation is y equals x cubed plus c. But I also know that I've got the point 1, 3. So I'm going to sub in the point 1, 3, and that gives me 3 equals 1 cubed plus c, so c equals 2. Therefore the curve is y equals x cubed plus 2. All right, so that's the end of our introduction to anti-differentiation.